How's it going, guys? It's
What the physics?
with Mr. Kidos. Today, we are going to look at an AP problem.
Make sure you subscribe and hit the bell so you get these videos right when I post them.
Let's go! Physics.
Howdy, let's take a look at this circuit. The first thing we're gonna do is color code. So we're gonna start with the positive side here with a high pressure red, and now we're gonna go to the negative side and go blue. Awesome. And now we're gonna pick a step over, make it green, and somewhere in between for this one here, yellow. All right, cool. Our goal, remember, is to kind of find that current through that 10 ohm resistor. Well, we need to kind of simplify our circuit so we get the overall equivalent and the 12 volt there. That means we can get Ohm's law to give us the total current at the battery, and that'll help us solve this question. So our goal is to make our circuit look like the one there. So the first thing we need to recognize is maybe the most complicated part of the circuit right there. It has to be simplified down. So between these 2 points, you see the voltage across 100 and the voltage across these other two should be the same. So we're gonna call this a component, the purple component, so that we have a 10 ohm resistor in series with that purple component. And if we can figure out what the resistance of that component is, all we gotta do is add them. If we look at the color code, we just steal it from the original one and we see it, we just simplified it down. So it's kind of like we zoomed out and said that section is just gonna be the resistance of those three resistors together, 1, 2, and 3. Okay, so now let's take a look at that section. So if we look at that little section, we have the 100 ohm resistor there, and we have these two little resistors here. That's the purple circuit. We're gonna call that like our little beige box. So we're gonna, between these 2 points, we're gonna pretend that's one other component that is worth the same thing as the 20 and a 30. So that's our little beige box. So if we look at our color code again, we can see that we have the same kind of idea. We have red to green on both sides. What is that resistance? So if we look at that little box, it's two resistors in series. We know what to do with series circuits. We just add them. The total resistance of that little section is going to be the resistance of number 2 and 3 added. That means we end up with 50 ohms. Sweet. Now that's going to go cascade back and see we have now a 100 ohm resistor in parallel with a 50 ohm resistor. So let's take a look at that parallel branch a little closer and see if we can figure out something else. So now we have this 50 ohm resistor in parallel with a 100 ohm resistor. That's our little section there. So let's look at arrow tails. You can see our color code is very similar, right? Just to double check that it's going red to green on both sides. So this voltage across the 100 is going to be the same as the voltage across the 50 ohm. That means if we apply Ohm's law, that the current times the resistance in one branch will be the same as the current times resistance in the other branch. That's good to know. When we do the arrow tails, the one with the most resistance is going to give us the least current. So we're going to call that one arrow tail. Right there through the 100. So one arrow tail is going to go through there. Now let's think about that. If one's going through the 100, how many are going through the 50? Well, it's got to come out so that 1 times 100 has to equal whatever that is times 50. Well, doing some basic math, we see it's double. So we know it's 2 arrow tails going through the 50, which means we know what it adds up to. It adds up to 3. We can now apply those arrow tails to our overall big circuit and see that, hey, we got 3 going all the way around through the 10 ohm, through the main line, and it splits off, becomes 1 at the 100. That's good to know because now we just have to figure out how much is 3 arrow tails to figure out our answer. So out of curiosity, what was the resistance of that purple section? Well, it would be the same thing as since 1 gives us 100 ohms, how much does 3 give us? Well, that would mean the resistance behaves like a 100/3. It turns out that's actually right because we used our proportional reasoning. That gives us that section right there is 100/3 ohms. Cool. So now all we have to do is add those two things together to get our equivalent resistance of the overall circuit. We have that number 4 resistor and the combination 10 ohms plus that 100/3 ohm resistor. That's going to give us 130 over 3 ohms, which is about 43.3 ohms. There's our overall resistance. I'm getting excited because this is almost done. The resistance of that purple patch, that whole purple thing, is going to be 100 thirds, and then we add that in, we got the total resistance. So now we can figure out, using Ohm's law, what our overall current is, which will give us the answer to this question. 12 volts divided by 43.3 ohms is going to give us 0.28 amps. There we go. That is the current through the 10 ohm resistor. Awesome. The next question was to figure out the total power. Well, cool thing was we know that equation. Power is just current times voltage, which we multiply those two numbers and we get 3.4 watts. If we wanted to look at the RIViP table, we can kind of see how this all gets organized and just kind of double check our work. Well, we have the 4 resistors, so I'll write those out here. And we have the equivalent resistance, which we already know. And I'm just going to put the arrow tails in. We knew that was 1, this is going to be 3 down here, and 3 down there, and 2 in between. Just got that off from the grid, and we know what 3 is worth, 0.28 amps. So if I know what 3 is, I know what 1 is. I just divide by 3 and I get 0.092 amps. So I'll clean that up really quick. 0.092 amps. Doubling that to get the 2 arrow tails, I get 0.18 amps. And everything else fills in because I already know what the values are. Now for voltage, I just have to multiply across both of those columns to get the voltage. I get 9.2 volts here. I get 3.6 volts, 3.7 volts if we didn't round, and 5.5 volts. See how those two add up. It's from red to yellow was 3.7 volts, and yellow to green was 5.5 volts, which is the same thing as red to green, 9.2 volts. Kind of cool how that works. Okie doke. That means the bottom one is 2.8 because that's blue to green is 2.8 volts. 9.2 volts plus 2.8 volts is 12 volts. So far, so good. Well, we already know the total power. We should be able to multiply across. Current times voltage will give us the power across each component. 0.85 watts for the first one. And we continue our math, 0.67 watts for the second one. 0.99 watts for the third one. And the last one is 0.78 watts. And if we add all those up, we don't quite get 3.4. We actually end up with 3.3 watts. But within our round off error, that is pretty much the same thing. So that works out. There you go. So let me summarize. So here you see the goal was to get down to a simplified circuit. We have 12 volts acting on a single resistor that's equivalent to get the same current. That way we can figure out what the current was at the battery, which happens to be the current through the 10 ohm resistor as well. In doing so, we wanted to take this very complicated circuit and break it down so we can see the components that can be simplified into smaller ones. So the first thing we saw was that purple section was in series with the 10 ohm, and we saw that because we went from red to green, green to blue. And then within that purple section there was some complicated stuff. So we saw that there was a 100 ohm resistor and this other branch that was complicated worth something. And finally we dug all the way down into that one and found out that, hey, those are in series, and that's pretty easy to do. You just add them. So that beige section became 50 ohms, and that helped us figure out what the purple was. We used arrow tails to help us figure out the overall current. We actually used arrow tails in a way that can be mathematically accurate, so that actually helped us solve it without having to do any crazy math with resistors. And so that means that whole purple section became the same thing as a 100 ohm resistor. When we put that together up here, we were able to add those two resistances together and get 43.3 ohms. And that's how we're able to figure out the current. And our arrow tails also helped us see that the current at the battery was also the current through the 10 ohm resistors. We basically answered the question, determine the current through the 10 ohm resistor. And last but not least, we had to figure out the power, and that was just done by a quick multiplication of the total current times the total voltage, give me the total power, 3.4 watts. All right, there you go. Thanks a lot.